So learning Git is hard, and as a trainer for GitHub, I can kind of give you a testament to that. It's one thing to be able to use Git; it's quite another to teach it to somebody else. So it's an interesting thing that I encounter every day that I go out and I teach a class on Git. So let me ask you this follow-up question: is who has had the opportunity to teach Git to somebody else? Raise your hand if you've taught Git to somebody else. Okay, leave your hand raised if you were successful. If you think you were successful. Awesome. All right, good. So a lot of the anxiety that I encounter from folks that are learning how to use Git is from the fear that they'll get themselves into a situation that they can't get themselves out of. So what I thought we'd do in this session is highlight some pretty gnarly but not too far off scenarios that you or your students might find themselves into, so that you can see it's possible to get out of pretty much anything using Git. So if you do want to follow along, this is where the repo is going to be. It's github.com. I'm Hector Sector on GitHub. It's called Git and the Bad Day. We'll list the commands up as we go through them as well. So we're going to cover porcelain commands. We won't really get into plumbing today. Once you've cloned the repo, let's take a look at our log. And so what I've done in this particular repo here is I've crafted a story modeled after Alexander and the Terrible, No Good, Horrible, Very Bad Day. I think I got that out of order. Who's read that book before? Perhaps if you have kids or, okay. It's a small group, so this will be an interesting practice, but that's all right. So this repo is just a story crafted after Alexander and the Terrible, No Good, Very Bad, Horrible Day. I'm pretty sure I'm mixing that up. So it's a simple repo. There's not a lot of code in it. It's mostly just text. But we'll work on this together. So let's dive right into that. So the first thing we'll talk about is how to find naughty commits with Git bisect. Sometimes we know there's a commit that's broken our build, but we can't place our finger on which commit is naughty, or perhaps our history is too massive to sort through hundreds of commits. So Git bisect is one way that we can find those naughty commits using a simple binary search. So let's run through that. Okay. So that's precisely what happened in my repo. So if you look at my log here, there's commit A15DE, and that's a commit that I added a section about BFG to my story. And then, so BFG is an alternate to Git filter branch. And so let's just say, for the sake of argument, that I wanted to exclude that particular section from my talk. Let's say that I didn't have enough time to talk about BFG. So I wanted to find the commit that introduced BFG. So in this particular case, that commit is nicely labeled, but we're working under the assumption that it's not always nicely labeled. So the way we start a Git bisect is with Git bisect start. And then you have to tell Git where you first noticed the problem. So that's why we see Git bisect bad, and I'm just going to point to my head commit there. And then where your repo was last in good shape. So in my case, I'm going to go ahead and do a Git bisect good. My repo was in good shape over in the starting commit, the very first commit that we made. So Git bisect start will get me started. Git bisect bad will point to the commit that has a bug in it. And then Git bisect good will point to a commit that I know is good. And so what then Git is going to do is it's going to run through a binary search, and it's going to ask me, it's going to check me out about halfway through my history, and it's going to ask me to take a look to run some tests, and those tests are customizable and scriptable. And once you take a look at your files and you run some tests, then you can see whether that commit is naughty or not, right? So in my particular repo, what I'm doing is I'm looking for a mention of BFG within my repo. So this particular commit that I'm looking at here doesn't have a mention of BFG, so I'm going ahead and labeling that as Git bisect good. So since that commit is good, what's happening is my history from that point on is going to be considered good. So we're going to start looking at the bad history, which is the other half of the history. Take a look at my file here. So I was checked out to a different commit here. In that commit in particular, there is a reference to BFG there. So we're going to label that as a bad commit. So we're going to do git bisect bad on that particular commit. Git once again checked me out to a different commit about halfway through that history, and that commit in particular doesn't have BFG. So I'm going to label that as git bisect good. And so what I'm left with here is I'm left with the commit that is the offending commit. It's the naughty commit. It's the commit that introduced the mention of BFG. So now that I have that information, I can go ahead and do things with that commit, such as revert it. So, but before I go on, all I need to do is I do need to reset back to the master branch because I'm left in this state where bisect has divided my history and checked me out to prior commits within that history. So git bisect reset just gets you back to your master branch. So now that we've found our offending commit, I want to make sure that it is indeed a naughty commit, and then I want to revert it. So revert's a fairly safe command, right? The revert doesn't alter our history in any way, our previous history. It's additive. It adds to our history. So the first thing we'll do is we want to look at that offending commit to make sure it does indeed contain a reference to BFG. So I'll just run a git show on that commit. And I'll see that that commit introduces the BFG line. It's not a very exciting line. It's just a couple of words that just say, I could have used BFG. You could also take that commit and you could diff it. So you could do git diff of the commit ID. And that's really the same as just doing git diff of the commit ID against my head pointer. So we're now ready to perform that revert. So we've used git bisect to find the offending commit. We've then used git show and git diff to make sure that it does indeed contain some content that in this particular case we don't want. And then what we'll do is we'll go ahead and revert that commit. So we'll do that with git revert. And as I mentioned before, revert is a fairly safe operation. It adds to our history. It doesn't alter our history in any way, our previous history in any way. So run git revert on that. And so because it is git and a terrible, horrible, no good, very bad day, that revert actually ends in a merge comp. Is that too loud or better? Same? That revert does result in a merge conflict. So we'll work through resolving that merge conflict next. So I'll take a look at my git and the very bad day markdown file here. And I'll remove the conflict markers. I'll remove the line that has to do with BFG. And then I'll save this. We'll stage it and commit it. And then we can run git diff, or in this particular case, git diff staged, because we have staged the resolution already. So we'll run git diff staged to take a look at what this particular revert does. In this particular case, the revert removes the offending line. So just to recap, we've used git bisect to find the commit that introduced the BFG line into our code, quote unquote quote. In this case, it's just a story. After we did that, we used git show and git diff just to verify that the contents of that commit were indeed what we wanted to keep out. And then we used git revert to introduce the inverse of that commit. And now that we've done that, that introduced a conflict. So we resolved that conflict by removing the conflict markers, removing the things we don't want. And now we're just taking a look at what's staged so we can go ahead and finish committing our resolution. So one thing is when you're also in the middle of a revert, like I was here, and I found a conflict, you can continue the revert with git revert continue, similar to how you can do git commit continue. You can use the continue flag on other git commands. And then Git is just asking us to input that last commit message. In this case, that commit message for the revert, which I am happy with the default message, so I'm going to keep that. And we can take a look at our history here. So just how we expected, all this adds is a new commit, in this case E342. And E342, in my case, is just the inverse of that commit that adds BFG to my story. So another common scenario is when we're working on a local copy of our repo, and we're committing directly to master sometimes as opposed to a new branch. In fact, I just did that in my example in which I reverted a commit, but I reverted it right on master. So sometimes we get ourselves into a situation where we've done that, and what we want to do is we want to move commits that we've made on one branch, say master, to a new branch. So we'll work through that scenario next. This is not a good idea, because if this was production code, I've now committed something to production code. It doesn't give us an opportunity to open a pull request and allow others to collaborate with us if we're committing this directly to master. I could end up with a broken build. So now let's take a look at how to move that commit that's on the master branch to its own branch after we've already done it. So the first thing we'll do is we'll create a branch, and I'll call this branch remove BFG. And so the next thing we're going to do after that is we're going to use a reset command. Because we're on the master branch, what reset is going to do is it's going to pick up head, and it's going to reset head to a previous commit in history. In our case, we're going to reset head back one jump in history. So we're going to go back to C2EB. But now that's because we're on the master branch. On the remove BFG branch, we're still going to have this history here. So that's going to give us the effect we're looking for, which is to have the master branch without that revert commit and the remove BFG branch with the revert commit. So I'll run git reset there. Does anyone know what the -- hard flag do? So yeah, so essentially the -- hard flag gets rid of my working tree. So whatever files come out as a result of that are not sitting in staging, are not sitting in my working area. So I just reset hard to one jump back before head, so I use head tilde to do that. That's within the master branch. You can take a look at our log here just to see that we are, in fact, within the master branch back to C2EBAEA1. I can check out to that remove BFG branch that I created just a second ago and take a look at the log there. And there we see that within that branch, we do have that revert of BFG. So we've taken one commit that lived on the master branch, and we've been able to successfully move it to another branch. There's more than one way to do all of this. And so one other way to do this is you could look at your, so let me just check back out to master here. You could look at your ref log. And so your ref log is a place of, it's a history of everywhere head has been. So we could, if we wanted to, cherry pick a particular commit from the ref log into one branch, in this case into our remove BFG branch if we wanted to. So in this particular case, you can see that revert commit commits E3427 is within the ref log. So we could cherry pick that. That would be another way to do this. You'd still have to reset your master branch like we did initially. So when you checked out from master, that new branch was based off of the master branch, so it included its history. So it's that checkout -b, the checkout is what created it. Yep, good question. All righty. So one of the defining characteristics of Git is that its history has integrity and all the copies of the code base are safely kept. And that's why we want version control. So, but this can sometimes be problematic when someone adds a large binary, say, to a repository, or maybe accidentally commits credentials to the repository. The problem is compounded if those credentials or that large binary file, is then pushed up to a remote. If it hasn't been pushed up to a remote, it's fairly straightforward to recover from that sort of situation, right? You could just do a git reset, and then you've recovered from that sort of situation. But if you have pushed it up to the remote, if you've committed some credentials, for example, well, there's other folks that could have cloned down your repo since you've committed your credentials. Any further commits that happen on top of your credentials will now contain your credentials as their parent commit. So there's a whole host of issues that could happen when you commit files with credentials in them to your project history, or perhaps files that are large binaries, which could just make your repository sluggish unnecessarily. So that's what happened to me here in this particular demonstration that I'm going to do now. And that is that I added a large binary to this repo. Not such a large binary. I really just added my keynote presentation to the repo. It's only about 10 megs. And what we'll do is, we just use as an example, we'll use git filter branch to help us remove that from history. And just as you saw, as I've been talking about a little bit earlier, you could use git filter branch. You could also use BFG to do something like this. But we're going to do it through git filter branch. So the first thing I'll do is I'll create a little history here to make it more interesting. I'll commit my keynote file to master. Okay, and git lol is just an alias that I created. It is for Git Log, and then it has some extra options in there to give me some branch pointers and labels, and to do some ASCII graph prettiness for me. So that's all git lol. This is just another version of Git Log. So if I look at my Git Log here, I can see that in this particular case, I've got a master branch with my keynote presentation on it. I've got my remove PFG branch with my revert that I did a little bit earlier. And we'll make it a little bit more interesting here. We'll merge the remove BFG branch into our master branch. And all the no edit option does is it just accepts the default merge commit message, which in this case is merge branch remove BFG. That's all that one did in particular. So what we've got is we've got a history in which we performed a recursive merge, a merge that was not a fast-forward merge. So that commit F7, F0 in my case has two parents. And I did this because I wanted to show you, we've looked at a little bit of a reset already. I wanted to show you a reset in a scenario in which you've got to reset past a merge commit that has multiple parents. So the first thing we could do is toy with that idea of the reset. So in my case, I've only added my one commit fairly recently. So the commit that I want to get rid of through filter branch is that commit in which I added my keynote presentation is 903D. But because I've merged now, F7, F0 could potentially be offensive as well as anything else that I commit atop of that, right? So the first thing we're going to do is let's run a diff really quick on those two commits, E3427 and 903D. And so the first thing I wanted you to notice is that this diff in particular I did with the two dots, right? So that's how I diffed those two. And you can run the same diff with those two commits using three dots. And this was mostly a fun thing to showcase. Has anybody played with this before, the two dot syntax versus the three dot syntax, and what the differences are? It's fun. It's fun, dorky stuff, right? So in this particular case, when we use the two dot syntax, what we're doing is we're taking a diff of the two commits against one another. When we use the three dot syntax, we're taking a diff of our last commit here, which in this case is 903D against the merge base. So 903D and E3427 have a commit that in their history that's their merge base. So it takes a diff against the merge base. And so that's why you're seeing here that when I use the 3-dot syntax, what I'm seeing is that the only thing that was added is that keynote file. Whereas when I'm using the 2-dot syntax, I see both the keynote file and I see my addition of the BFG. It's a little easier if we look at the log to explain too. So the next time I look at the log, we'll take a look at that. So armed with that information, so by the way, here's that log we were looking at just a second ago. So we were looking at E3427 and 903D. And so the 2-dot syntax gave us a diff between those two. The 3-dot syntax gave us the diff between 903D and the merge base. And you can see from the graph here that the merge base is C2EB, right? Because that's where they have common ancestry. So I'm going to reset past this merge commit here. I'm going to do a reset hard again. And I'm going to use this syntax here, head tilde 2. So when you're resetting past a merge commit that has multiple parents, right? In that case, that F7, F0 has 2 parents. You can specify which parent you'd like to reset to. And so the tilde 2 syntax will take care of that for us. If you want to reset back to the first parent, you could just do git reset --hard head. And you can jump back 1. So when we do that here, you can see that we've now reset back to E3427. So this has effectively done for us what we wanted, which is to remove the addition of that keynote file. So as long as I haven't pushed my commit up to these commits up to a remote, this is not a problem. This was a fairly easy fix. However, if I had pushed this up to a remote and then other folks had committed on top of it, we would need to go through our history and filter out any mention of that keynote file. Or in the case of passwords and things like that being committed to history, we'd have to go through the history and clear out any mentions of those credentials. So that's where Git filter branch comes in. We'll take a look at that now. So I'll reset back to the state that we started in, which is where we had the merge commit before we did the reset. So just wanted to show you that there. So this reset command just brought us back to that starting point, just to make it seem like we didn't get rid of that file at all. So we'll try filter branch here. So your filter branch command can run using a number of filters. In this case, we'll use the tree filter. The tree filter rewrites commit trees and their contents so that we can completely scrub out that keynote file, which is what we want to do in this case. And then we'll run the command, we'll specify the command that we want to run on every commit in our history here, which in this case is just to remove that particular keynote file. And then we've also specified in here head, which is where we'd like the preserved history to be maintained. Or sorry, the rewritten history to be maintained. So what will happen at this point is we'll have in our repository both the new history without the keynote file and the old history with the keynote file. If you'd like to look into that, we can peek inside the Git directory, the .git directory. So here we'll notice that the original history is saved under refs original. We'll remove that under the assumption that it contains, let's say, password-sensitive information, unwanted artifacts. So we'll do that with update ref with the D option. And we'll also immediately prune our ref log, and we'll do a little bit of garbage collection. And just to verify, we can take a look at that refs directory within the .git folder one more time, just to make sure that that's gone, and it is indeed gone. Now, a couple of things to note is if you've pushed this up to a remote, like github.com, for example, it's possible that that remote is caching some of these refs for your project. In fact, github.com does cache these things. So even if you've cleaned it out from your local repo, in the case, you may have to contact support in order to get that stuff, that cache cleared from github.com. GitHub or any other support staff also can't control how other folks clone your project and what they do with your project, right? Like everything else out there on the internet, once it's out there, it's been out there. So if you push something like this up to the remote, you can do your due diligence, you can try to scrub it out of the repo, but it's completely possible somebody will have grabbed it at some point in time. And a lot of folks also have trouble with Git filter branch. There's a lot of options to filter branch. So you can check out Roberto Tiley's BFG repo cleaner, which we talked about a little bit earlier. I didn't revert it because I didn't like it. I just reverted it as an example of something to revert. And that's a little bit easier to use and can sometimes be faster as well. So just out of curiosity, who's used filter branch in the past? Okay, a handful. Who's used BFG in the past? Okay. So a lot of more folks used filter branch than BFG from the hands in the room. Okay, so now that you've seen us get deep into Git porcelain commands, I thought we'd have a little bit of fun, and we go back to that book that I talked about a little bit earlier, which is Alexander and the Terrible, Horrible, No Good, Very Bad Day, and we'll put a little journey together into a story. It's my hope that that little bit of a story will help kind of bring everything together for you. It's also my hope that as you're taking some of the things that you're hearing at the conference and you're teaching some of your friends that a lot of you were actually really successful in teaching, that you'll take some of these tidbits back with you. So now I'll read you a story. So grab your blankie, your pillow, your milk, and your cookies, and follow along with Git and the Terrible, Horrible, No Good, Very Bad Day. By the way, I don't have kids, so I don't often get to read stories, so this is fun for me, okay? These are original illustrations, so they're awesome. I didn't draw them, but they are original illustrations. All right, here we go. I did some late night committing, and I thought everything was fine. And when I got out of bed, I spilled my morning coffee, and by mistake, I started a software update on my machine, which bricked it for most of the morning. When I finally logged on, I realized I committed part of this story directly to master, which is horrible practice. So I could tell it was going to be a terrible, horrible, no good, very bad day. So I decided to do some Git bisect, because on any other day, it would probably help me find the commit that broke my story. Besides, my friends Matt and Eric, who are not here, always found their bugs with Git bisect. Those are the bugs. See, it's cool. My most recent commit was obviously bad. And I don't even remember the last time I looked at my story, so I figured only my first commit was safe. It took a couple of tries, but soon enough I found the commit that contained the offending line. But when I reverted the commit, I got a merge conflict. And that's a blurry merge conflict. When Matt used Git bisect, he reverted a missing semicolon, a misspelled variable name, and a pretty alarming lack of comments. That's a true story about Matt. When Eric used bisect, he reverted some missing environment variables, some badly indented blocks, and part of his grocery list that got accidentally pasted into his code. When I used bisect, I just got a gnarly merge conflict. After breakfast, Brianna, who's also not here, but she's from Chicago, got to teach her favorite group of students. Cynthia spent some time watching trains with her son. I was stuck trying to figure out how to resolve a merge conflict. I could tell it was going to be a terrible, horrible, no good, very bad day. Before lunch, I treated the conflict as I would any other conflict. I opened the file and removed the conflict markers. Then I wondered, how do I finish this revert? Git revert didn't work. Git commit didn't work. I wish I could revert this day. Once the revert was finished, I realized I should have done it in its own branch. I wanted to Git reset this terrible, horrible, no good, very bad day. Nobody warned you about all the cheesy Git puns that day. That's what it was, because that afternoon I actually tried Git Reset. My commit was made to the wrong branch, so I figured I'd create a new branch, then reset to the previous commit. And when I switched to the new branch, my revert was there. I then realized that Git cherry pick would have done the same thing for me. I wish I could cherry pick myself out of this day. Later that night, I realized I uploaded my keynote presentation binary to the repo. What a waste of space. I figured I could just revert the commit, but that just means that any previous commits would still have the file. This was a terrible, horrible, no good, very bad day. Because each commit is a complete snapshot of the code base, and I had no idea when I committed the binary, I knew this would be a messy cleanup. But Git filter branch should help me figure out this mess. But before bed, I was successful with Git filter branch. I was happy with myself. But then I realized a local backup of what I had cleaned up was still in my Git directory. So I had to clean that up too. I pushed my changes up to GitHub, and my push was rejected. It's because my commit history was altered, so I had to force push. Cynthia then told me that GitHub caches commits that may still have my credentials. So I had to contact support, and they removed the cache commits from GitHub. This was indeed a terrible, horrible, no good, very bad day. My friends say that some days are like that, even without Git. But Git did indeed stick with me through every sticky situation, and its integrity was never compromised. So hey, Git helped me navigate my horrible, terrible, no good, very bad day. And that's the last story I'll ever write. Thanks. So a couple of quick shout outs. So versions of this talk have been given in the past. So Alan Smith gave a talk like this one at last year's Git Merge. Was anybody here for that one? It wasn't in the same style, but it was how to get yourself out of sticky situations. And then Katie Seiler-Miller has a wonderful website, oshakit.com, which is just how to get yourself out of these sticky situations. It's a great bookmark if you haven't checked it out. And so same kind of vein here in that we're kind of following that. So just wanted to do some shout outs to them. So with that said, I'm happy to take some questions or to take them offline if we want to. Yes? Oh yeah, I can. So I'll upload them to the. Say one more time. I'm not sure I heard you. Let me go back there, actually. Oh, yeah, of course. Thanks. And I can also, I can take this binary and put it back over there. You talking about this one? Yeah, sorry. There you go. Say that one more time for me.
Just right now.
Show the slide, please. Oh, show the move commits to, yeah. Absolutely. You'll get to see it replayed. Let's see if we've got it.
I think your commit message is tricky, because you are not really doing commits.
Absolutely. Yes.
And then you are just removing commits from your branch.
Mm-hmm. Yes. You're right. That's probably more of a result of some late night writing commit messages. Yeah. So absolutely. So you're absolutely right. So it's as we talked a little bit earlier, it's that checkout command that actually creates a new branch based off of the commits in master. So this git reset command doesn't actually move the commit for me, but that's the effect. So what ends up happening is essentially to the naked eye, that's what ends up happening. Technically, it's not what actually happens. So you're absolutely right about that.
To be honest, no commits moved at all.
Correct.
On the rest.
Correct. Absolutely. All righty. So that's it. Thank you so much. The next talk is at 10:20, and you'll get to see me again, and I'll have a friend with me. So take a 5-minute break.